Okay, we've got another interesting integral here from MIT Integration Bee 2025 quarterfinals, round 1, problem 1. We have the integral from 1 to infinity, x to the 5th, e minus x dx. Okay, the one thing that slowed me down on this one is just this lower bound. Because if it's a 0, it's going to be a Laplace transform, and then it's going to be really quick because we can kind of do, that Laplace transform is going to be really simple. But with the 1 there, it's a little more complicated, so I have two ways to do it. So I think I'm going to do two different videos on it. One will be the very straightforward method. We'll do integration by parts. The other one, I'll still do a Laplace transform, but it's just going to be a bit of a harder Laplace transform. So we'll do the integration by parts in this one. I'm going to do the DI method over here to the right. If I differentiate x to the 5th, I just need to differentiate it a whole bunch of times. Eventually, it's going to be 0. In e to the minus x, that's going to be easy to integrate. So let's just go ahead and differentiate this, I think, 6 times until it's all the way to 0. And then over here on e to the minus x, that's going to be easy, just alternating signs, because every time we integrate, a minus is going to pop out. So then when we do it again, the minus is going to turn this minus to a plus, and we're back to e minus x. And that pattern is just going to repeat all the way down to the bottom here. And then next we'll have our solution on the diagonals. Let me see if I can line this up. Now we have, I was going to say we've got a minus sign on each one, but that's not quite true. Oh, definitely a mistake here. I went plus plus, so this needs to be alternating signs. So let me just fix this. Okay, so now we have it, so each of our diagonal terms is going to be negative. We either have the minus sign here or the minus sign here. So when I write this all down, let's factor out minus e minus x. And then we just need to copy down all the positive versions of this over here in this column. The last row is going to be zeroed out, so we don't have to worry about the 0 integral. We just need all this stuff here. And now we're at the point where we just need to evaluate this thing. The nice thing about e to the minus x, when you evaluate at infinity, this goes to 0, and it doesn't matter what all this other stuff's doing because the e to the minus x is going to be more powerful. You could prove it out with L'Hopital's rule or something, but we just don't have to worry about the infinity on this. So we're just evaluating the last part. We're going to have a minus when evaluating. So minus times minus is plus. This becomes e to the minus 1. So I'll write that as 1 over e here. And then we're just plugging 1 into all this stuff. So we get 1 plus 5 plus 20 plus 60 plus 120 plus 120. But totaling up all this stuff, this is just going to be 326. So putting it together, for my final solution on this, we just get 326 over e, and that's it. So that went pretty quick. It might actually even be easier than the Laplace transform I'm going to do in the other video, but I don't know. We'll do that one and I'll see what happens. That one should be pretty quick too, I guess. So that's it for today. Thanks everyone for watching. Have a good day.